So I'm going to talk about PGP, and you're going to say, what? PGP, isn't that like obsolete in these days? But it's still not really good for email, but it's great for code signing. This is exactly what we're going to talk about today for code signing. And this is really weird when it's 15 seconds. All right, so Git is not a blockchain. You may have heard somebody say, well, Git is the original blockchain, but it's not. It is a chain, yes. It is not block. It is also provides no proof. Blockchains are decentralized, many to many. Git is one to many. You can actually have an interesting tool called Git blame someone else. You can see that Linus committed to it at some point. Says, you know, hey, I am actually Linus, but it actually was not. It's Google for that. That's actually a pretty neat tool. When you commit something like that, it says you're now a jerk. How much do you trust your teammates, your bosses, your members of your free software project, administrators of the GitHub, Microsoft? Should have looked who was the main sponsor for this event before I put that there. So can push equals can spoof. Certain conditions apply. If you already have this repository cloned and you pull Git repository with rewritten history, there will be an error. But you'll probably just delete the repository and reclone because you're like, Git just gives weird errors, right? All right, in 2011, kernel.org was breached, as everybody might know, but it's okay. You know why it's okay? Because the Git tags were signed, PGP signed. And we're going to look what that actually means. What is a Git tag signature? There we go. So if we cat file for the 419 RC6, that's when I wrote these slides, you can see that it's got object hash. It says it's a commit. It's got a tag name. It's got a who tagged this. And this signature right there, it confirms all of that data above. We can actually look at the commit object itself if we cat that object and say there's a tree hash, there's a parent hash, what came before it, there's an author, there's a committer, and there's a commit message. So we've assured all these things in this little, it's still, all of that hashes to that, what the object hash is. But what is in the tree hash? A tree hash, if we look at the actual tree hash, it's got blobs and the trees. And the trees are just a collection of blobs that have also been hashed. So it hashes all the way down. Basically, that's what Git is. Changing anything in the repository will result in a different tree hash. Yeah, do you understand? If we change any part, file permission, contents of it, name of it, the tree hash will be always different. Any changes, even one small byte, will have a different hash for the tree. Changing anything about a commit, author, date, that tree hash, or anything like that, will result in a different commit hash. So if you change any of that data using Git blame someone else, your commit hash is going to be different. And changing anything in the repository history, anything that came before this commit, will give you a different parent commit hash. With me? So, what does that mean? Signed Git tags. When you sign a Git tag, you create a cryptographic assurance that a cloned repository and its entire history are exactly, byte for byte, the same as on a developer's system. It's a little spiral. It goes all the way down. Like I said, it hashes all the way down. So Git tag S-S is a nature's immutable crypto chain. It is not a blockchain, but it is a crypto chain when you actually get PGP sign that tag. You can also sign commits using capital S. If you can protect the entire tree by signing the tip commit, because it all just percolates down through the parent hashes. Useful when multiple people push to the same repository. It's great for digital forensics if you need to figure out who pushed what at what point, and you actually can prove it. But this means that you have to be very careful about protecting your keys. You should treat your PGP keys as a developer's proof of identity if you're going to sign code with them. Store the master key offline, puts up keys in a hardware token. I know this is complicated, I know this is hard, but as James mentioned, we do write guides, and I do write guides, and do have a very nice guide that is very handy. It goes in complete detail on how you can do it. We have a guide. There's the URL right there at the bottom, and I will keep that URL there for a few slide changes, for which I'll just stand in here and look at it. It covers all you need to know, PGP basics and best practices, how to use PGP with Git, all the details on that, and how to protect your developer accounts at GitHub, GitLab, and so forth. It will also thank you at the end. I forgot there was no more slides. All right, thanks.